Thank you. So first of all, it's great that you are all here. Last session of the event, I can see many kind of luggage here. So you have plane to catch. So I will try to be quick. So next 2.5 hours we will be spending on Fabric and all the internals there. But first, Sami, here is your badge. Please pay the suite when you go out. I promise that you come there and pay for the whole weekend. Thank you. So my name is Vesa Tikkanen. We've seen very famous titles for everyone during the event. I'm a consultant at Kumio doing data things on Microsoft platform. SQL Server MVP. And then data platform MVP like 5 years after that or something. What I do on my other time when not working on Microsoft data things, I'm building a lakehouse. Not Fabric lakehouse, the real lakehouse. So and technically, like building as this summer, the yard or kind of the place where cars can be and things. So quite a lot of bricks. I have a son, 17.5 years. To him, to get the driving license as a car, those need to be on correct place. That's kind of the idea. And if you say that there are a lot of bricks, there is even more. And not that we will build a road to the lake. So even more, and of course to the main entrance. So even more bricks. So but anyway, 74 pallets of those for this summer. So we have this program on television show on Finland where they try to find the kind of best summer cottage of Finland. And then they have the kind of every show starts for the family presenting the cottage. And then they open the door and say, welcome to our cottage. And that's what I've been telling to everyone, that welcome to our summer cottage. Please bring your kind of gloves with you when you arrive. I have plenty of things planned for you. And still first to be arrived, so no one has yet come. Who is Power BI user? Who is Fabric user? Okay. Who was Power BI user? Why didn't you raise your hand when I said that why are you not a Power BI user? If you Fabric user, if you are Power BI user, you are Fabric user. That's kind of one first thing from this session that there is no, I would like to say, there is no difference between Fabric customer and Power BI customer because it's only those workloads you enable. And that's actually a big thing, at least in Finland, in many companies, that they are like, oh, we are not going to the Fabric, it's that big of a thing. And then you're like, but you are using Power BI very heavily. Yeah, but we are not going to the Fabric. And you're like, it's like a one switch, and you enable additional workloads. So the purpose of this session is to try to lower the bar for you to try Fabric things. That's kind of my idea of this session. It even says on the Office 365 portal admin, I don't know what it is, that it's a Fabric administrator. There is no such thing as Power BI administrator. So anymore. So kind of if you are Power BI user, you are Fabric user. Okay. What are we going to talk during the later part of the session, or pretty much starting right now? We are doing pure demos. So we are at the end of slides, pretty much one slide left. We are talking about real customer case, Atria. So they have it's a food manufacturing company here in Finland, something like 2 billion euros turnover per year. They have a huge on-premise installation for all the SQL Server things, analysis services and databases. And they are, as a food producer, they are tied to all those EU regulations regarding traceability and things like that. I don't know, they have to find the chicken which was used, and then kind of the food that the chicken ate, that if something goes wrong. So the kind of data loads are quite heavy. And our purpose on this meeting, or on this session, is to reduce this one. They have had a SSAS model, which they needed to refresh. Refresh took 1.5 hours. We need to take that time as short as possible. And that's the 5 minutes to load, 5 minutes to analyze. That's the was the goal on that exercise. So pretty much, this is their on-premise architecture, easy. I asked from the Copilot thing on the title. Yes, there was a Copilot word on the title. That's actually a hype term. Everyone wants to use the Copilot term, so I put it on the title to be selected on the session, because kind of otherwise you would be listening something else. So I know that I have to put it there. Then I have kind of possibility to be selected. So, but Pasi and others will be mad to me if I don't kind of then use the Copilot. So here we go with the Copilot stuff. I asked from the Copilot, please give me a picture of the Fabric architecture. And here we are. So that's Microsoft Fabric architecture. Not so good. I rephrased the term. Give me a lakehouse architecture, because that's what it is. So that's the lakehouse architecture. Okay, Sami on his session said that he needed to prompt like multiple times to get the picture correct. I did the same thing, so I asked that, could you please add data lake and batch processing in the architecture, and this is what it came. So kind of, we are getting there. It's becoming something. And then, if you ask that, okay, give me kind of the session title that let's load data from on-premise to the Fabric Lakehouse as very efficiently, and this is what it came. So kind of good things. Highlights for the session. It's good to be after security session, so let's get this out of the table immediately. It's even better. I don't have because this was a new idea, I don't have a kind of something to give you yet, but if you go that q7.fi with your browser, the same list is there. When I'm kind of reached at the end of session and you have ticked all the boxes, who was the first to kind of see that, yeah, every one of these issues have been shown, then that's the winner. These are important things. This is not like I'm joking that don't care about these things, but it's that in this session we are cutting corners and doing things because we want to learn Fabric, but you have to take care of these ones when you do things in production. Yeah. So let's go to the actual thing. One more Copilot thing, because this is important. LLMs are as good as the data that they are trained for. So in this exercise, if you would ask from Copilot that how can we achieve this one, The answer it gives sounds correct, but you cannot create shortcuts against a SQL Server and databases, and kind of the answer is way wrong. So kind of Copilot doesn't help here. Yes, there is a Fabric Copilot, or actually there are like 7 different Fabric Copilots. As of today, how you interact with Copilot in Fabric is that you already make a decision that I will go to this experience or workload, and then you ask how I do things here. So if you know what you are doing, you're actually slowing yourself down by asking things which you can kind of click in the user interface or doing something, because they are not integrated. Hopefully someday we will have a Fabric Copilot, but as of today, we have a Copilot for Spark, we have Copilot for SQL, we have Copilot for data pipelines, we have even Copilot for data flows inside data pipelines. And if you ask from those, that how should I integrate with my on-premise data? They are kind of, yeah, you already picked me, so let's go with this solution. So it's kind of, I would say, we can do better. And that's why kind of let's let the Copilot evolve a bit in Fabric. That's my kind of output of this. Okay, so we are starting our journey towards the final report. We have data in on-premise SQL Server here. So SQL 41. I name my servers with the incremental ID. And now I'm in the SQL 41, so SQL 42 will be next one and going forward. That's a good thing, because you kind of, I don't know, it sounds a bit weird if you say that you get in love with some servers, but kind of you have favorite servers. So SQL 9, for example, that's a perfect SQL 2012 server. It's just perfect. But 41 is a good 2022 server also. Here I have a data warehouse, AdventureWorks data warehouse, because why not? And this is something we want to upload to Fabric. What's our purpose is that we actually want to minimize the 1.5 hour timeline. That was the purpose. What we want first to do, we want to get data up to the cloud. You could use data pipelines, copy data from SQL. You could use data flows, Power Query, to read from on-premise. What we did was actually kind of neat, I would like to say. I'm very proud of this one. So what we did was that I have a storage account, globally reachable storage account. Now, tick a box. Not in production, but in this demo. And here I have one container with folder structure. And on the SQL Server, what I have done is data, blah, 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 external resources, data source tied to the Azure storage, and data format for Parquet. Native SQL 2022 functionalities. Then we have developed a stored procedure which takes as first argument folder, what you would put, where do you want to land your data, and second, a dynamic SQL. Yes, you could argue that it's not an optimal thing, but there is a reason for that. What's the output of the statement going to the lake? And then, if you run this one, let's take a new query because I want to receive that window for you. Fact internet sales is a table, and there I will put this one as demo 2. And if I run this, it will take like 1 second or something. Okay, it's 60,000 rows. If you fact internet sales medium, there is something bigger table somewhere, medium 10 million, and you run this one, 10 million rows to upload to the Azure takes like, hopefully not so long, 6 seconds. You never can do that speed in any of the Microsoft recommended built-in already available things. How does this work is that on SQL Server, how many cores you have, you can set up the polybase connector so that it uses all the cores. In this device, I have 40 cores on the SQL 41. So 40 different threads. They are selecting internally from the database on the table and writing independently to the cloud. What happens is that here, I think it was demo 3 or something, what we, fact internet sales, what was the name of the folder I put there? Fact internet sales demo 3. Fact internet sales demo 3. Happens 40 different files in the size of 3 megabytes each. So that's what happens. We did this for something like 2 terabyte table, and we managed to reach, kind of cap the 2 gigabyte connection, private link, Azure private link connection to the cloud. It was capped the whole time. So kind of the speed of this technique is way faster than anything else. I would like to say, as of what my assumptions are for the upcoming mirrored databases for SQL Server, that you will look for that feature, and then you will come back with this technique, even though that's like native Microsoft thing. So we have data in Parquet format at the cloud. What should we do next? On Fabric side, not this one, this one. On Fabric side, I have a workspace. First of all, for those Power BI users who are not Fabric users, I'm using, just because you can, always the powerbi.com URL to use Fabric, because kind of how else you could say to people that, hey, this is Fabric. I'm not using fabric.microsoft.com. I'm using powerbi.com to use always Fabric, because it's the same thing. I have here a notebook, few lakehouses, and a warehouse. Difference between lakehouses and warehouses is that they both are visible in every engine. This morning, Heini talked about different workloads. Lakehouse and warehouse, you can connect Management Studio with that. So it's a database. It's a SQL database you can connect to. Lakehouse is read-only. Warehouse is something you can write with the SQL endpoint. And the other way around, that on this Spark engine or scripting, we can write to Lakehouse, but we cannot write to warehouse. Kind of the only difference is that they are storing data in the same way, they show up everywhere, but it's the who is primary. Kind of, is it the Spark engine or is it the SQL engine? Warehouse, SQL, Spark, Lakehouse. And that's kind of the thing. Now we have the data in the Azure storage. So I will first open the Lakehouse. And inside a Lakehouse, you can create what's called a shortcut. So inside a Lakehouse, you create a shortcut and point it to your ADLS Gen 2. And when you do this, I have done this already, so I will cancel. When you do this, it shows up just as a folder. So tying up different storages here and there, you create a shortcut, and that creates a folder. That's a folder even in a sense that if you open a notebook, multiple terms, sorry, the kind of this morning, some of you raised hand that I have never used a Fabric. Then you visited Heinis session, and now you're a Fabric expert, so we can talk like these things in fluent manner. So here I have a notebook, which is an engine that I keep running using Python or PySpark to run workloads on top of Fabric Spark engine. So here, if I remember correctly, yes, here I have Python script. It imports OS library, which has nothing to do with Spark or Fabric. It's basic, like Python library as it can be. It has a listdir method, which lists the content of the folder. So if I go with kind of pure Python to my lakehouse, which is attached to this notebook, first of all, starts in 5 seconds. Fabric Spark sessions start in 5 seconds. Kind of the whole cluster is available for you in 5 seconds. How cool is that? Like never before seen functionality. Of course, Microsoft has like a bunch of clusters available, and then they just attach your session to that. But anyway, from customer point of view, 5 seconds to get things running. Cool. So I list my operating system's root directory. We learned just that Linux is a good operating system, so here are a lot of Linux folders, and here I have a folder for Lakehouse at the root. So if I put Lakehouse, rerun the query, there's a default location. And then I look inside a default location folder. There are tables and files. These happen to be the same thing as if you go with there's a program or application called OneLake Storage Explorer, which is attached to the Windows Explorer, so you can browse the OneLake content with it. If you go there and open the same folder, there is a tables and files folder, and here are tables and files. This is just hidden. You would need some parameters for the method to show hidden folders also. But kind of, it's very easy to use Fabric Spark to connect or manipulate files through shortcut from ADLS Gen 2, because they are just folders. If I go here underneath the files, there is that external thing or something external, and there external I had a shortcut and I could go there. Why this is important? You could have a Python script that doesn't understand anything about Spark or ADLS or something, and it works. If it works in Linux, it works in here, because these are just folders. And that's actually something, because there are, for example, Excel libraries out there that I use in some customers. Yes, someone uses Excel as their data store, and we need to manipulate those files. Kind of, they don't understand anything about ADLS or ABS file paths or something like that, but as these are just folders, we can run them here. Very good. Another thing, what we learned during this exercise is that if you have something somewhere here, if you have something you can install or you need to install. If I run import hello world, that doesn't work, hopefully, because this session has expired and it should now be unavailable, hopefully. You can install additional things to your Spark session just by pip install, like you do in Python. You can do that on Fabric. You can also create something called environments. I'm not sure if Heini talked about environments in the morning, but yeah, you can kind of pre-configure the environments you want to use. But when you do that, you lose that 5-second startup time. Because then you cannot use the pre-configured Microsoft cluster for your system. So when you are kind of wanting to use external libraries, what we did was that we always, on the notebook, installed them live. We get the 5-second startup time and like 10-second library installation time, so 15 seconds, much less than 5 minutes what the environment system requires. So kind of tip first, use pip install inside your notebooks, not environments, even though Microsoft is pushing those environments for you. Okay, then we now have the shortcut. We have Spark session or notebook. Let's take this Copilot thing away. and then we want to read the data. This is not the production version of the code, but it's easy to present on here and easy to understand. This is something Heini did also in the morning. So we created a table from Spark data frames. Here, I'm just iterating over all the directories where I have loaded all my tables. So if you looked within the Azure storage, not that one, but this one, I have loaded all my on-premise tables with that stored procedure to the cloud, and then I can easily iterate over those and load them as a Delta table. Okay, it creates a copy. Yes, it creates a copy of the things, but you can kind of reload the things on the Azure storage without affecting the final output, and you kind of get this staging warehouse type of thing that you can do that. And for smaller tables, we did this kind of loading every time with the replace or overwrite, and then reloading small tables over and over again. For bigger tables, we used something called convert to Delta. So what we technically did was that we read through all the files in the ADLS and created the Delta metadata on top of that. It didn't read the whole files, it didn't have to, it just read the headers, but it created the JSON files for Delta format for us. And then we could do, here, we could do an upsert to our table. So we can read from the ADLS Gen 2, which is now Delta table, because it's been converted to Delta, and upsert to our main Lakehouse table. So I'm overriding, partitioning, sorry, not even that one, that was incorrect, there is a where statement. Here, I'm overriding Delta, replace where year is something. Of course, parametricized so that you kind of get the idea. But here, I can kind of reload. This is a huge, let's assume that this is a huge table. Multiple years, 2 terabytes of data or something. I can read from ADLS only those files that should be replaced, and then I'm replacing the Delta table inside a Lakehouse. And kind of that is way faster. This one takes now 6 seconds. This doesn't have a lot of data, but in the real time, the most of that 1.5 hours time was used in the big fact tables. And by doing this technique, we get to the 13 minutes. From 1.5 hours to the 13 minutes. Including the uploading part. Kind of already including the uploading part from the SQL.
Can I ask?
Yeah.
With the big table, like when you do the export to the database from the SQL server, you can't find with like small files.
Correct.
Did you do any sort of like optimization action or anything?
Yeah, that's a good question. And we actually agreed this one before the session. So kind of it sounds like it goes very fluently because we had this discussion that asked that question on this one. The question was, what about the optimization? How those files, you had 40 files, technically can be 80 if it's a big enough table because SQL Server creates 500 gigabyte files, and then when you reach the limit, it creates a new file. But yes, there could be multiple small files or bigger files. How should you optimize that? This one, when you use kind of read from ADLS, save to one lake house, uses a Microsoft internal thing called vOrder. There's a Spark optimization technique not available in open source. And what does that do is that when we read the original file here, I have now, this has been by purpose created to the ADLS with maxdop equals 1, so 1 core, so that I get that one big file. 100, because it's easier to show the size, 108 megabytes. When this is being read from the ADLS and saved to the one lake, what happens? We go and look the tables section here, it's 16 megabytes. So that's actually one of the kind of why Fabric Spark and Fabric SQL are so fast, is that the vOrder technique that they are not releasing as an open source does a very heavy compression. It's not available in SQL Server. That's why SQL Server Parquet files are so big. They are compressed with the snappy compression, but they are still 100 megabytes. Then vOrder plus the same snappy compression, and you get 16 megabytes.
I was more kind of wondering about the first step where you run with the 64-core parallel write, and you get a bunch of, like when they run in parallel, when you showed it was like creating minimum 3 megabyte files.
How the same technique, this will optimize the same thing. So the question would be that 40 files to a smaller number of files.
Yeah, or like let's say if you have 10 billion rows, that will mostly create you 100,000 files, each 3 megabyte or 10 megabyte, and Spark is not really good with
Correct. That will, the saving as a new table will kind of optimize that on the fly. You are absolutely correct on that one. That kind of you are measuring that 13 minutes that I said that I will need to run, and you are absolutely correct that optimized number of files is somewhere in the size of 200 to 1 gigabyte, 200 megs to 100 gigabytes, somewhere there. It depends on the clustering size and things like that. SQL Server creates 500 megabyte files. So you could get 40. That's the kind of your bad position, 43 megabyte files. But if you have a huge table, it creates 40 500 megabytes tables, and then starts new 40. So kind of you are in the ballpark of the most optimal situation. So that's kind of, but they are big files. We needed to, or in many cases, we wanted to copy them from ADLS to one lake using Fabric Spark because we get this compression benefit. But actually, we will go there because some tables we need as fast as possible, and we are don't care about the compression because we are like looking for the latency more or less. So we will get there very, very shortly. Okay, so we have now tables in a lakehouse. How can I use them? Well, if you go in your workspace, on top of any SQL endpoint, you will get a connection string, server name. In Fabric, one workspace is one physical thing. I'm not sure if that was kind of understood before, but you cannot, the limitation why you cannot reference tables or databases from other workspaces is because workspace is the server cluster, but basically for us, the server or endpoint. And this connection string is the same for each SQL endpoint, so basically each database. So when you use your Management Studio Connect to that endpoint, you will end up here. You can see all the databases that are on that specific workspace. So now, I think this one is the incorrect workspace, but this is the workspace. Yes, this is the one we were looking for. So when we now have landed our data to the lakehouse, they are already here on the SQL endpoint. So kind of analysis and reporting if it's based on the SQL engine or kind of SQL endpoint. So some kind of reporting or something can be done because this is now already queryable. You can actually create these tables or create a table from the shortcut itself. So to your question, kind of, or adding to your question, this table is table that actually the data is still on the ADLS, shortcut it, create it as an external table here, and you can query directly that. So you get rid of the copying part. If some of your data is so that I don't care about the compression, I want them to be just as fast visible as possible. No, that's still on the cloud. This was also a question that we agreed beforehand. That's still using cloud infrastructure. So that's a shortcut from one lake to the ADLS. And it's something that Microsoft doesn't tell officially what it is. But technically, it's not poly-based in a sense because it's done in the file system level. So but we will get there. And good thing for these ones is that when you create, we were targeting about the tabular model refresh. If you go on top of your lakehouse and you create new semantic model, you can choose all the tables you want from your lakehouse and create a semantic model from them. Basically, tabular model or tabular Power BI model or however you want to call it, semantic model nowadays. This one even includes the shortcuts. So kind of that 1.5 hour processing time on the on-premise infrastructure is now going away because these models don't have to be refreshed. They are the data. So in that very specific moment when my stored procedure on SQL Server lands the data on the ADLS and that shortcut is pointing there, my Power BI report referencing the semantic model has the new data. And that's kind of cool. Kind of the direct lake mode is one of the key things within Atria case, where they are not getting rid of the on-premise infrastructure, they want the cubes to process as fast as possible. So now we are in a step that we are not kind of processing cubes. We are selecting from the database, saving Parquet files, and immediately we have the data available for end users to consume. Okay, I have 9 minutes, and we still have one thing to cover. So, what about very big tables, like terabytes of size of tables? Uploading them, even in a partitioned manner, could be hard, because there are tables that kind of the lead or the lag, I don't know which is the correct term, but kind of you can have updates up to the very old rows. So we need to upload a lot of rows to be sure that we have the latest data. And if it's a huge table, we just don't have time for it. So how could we make this even more performant or latency, less latent? Is that English? So what has come just recently is this one. There is not the official public documentation, but the feature is public. It was introduced in build. Hopefully they will come up with some kind of blog post or something. But you can choose the S3 compatible bucket. And for this one, you can use Gateway. And this is interesting, because you can have S3. Look the username, Sami. Now you need to look admin. I just need to remember the password. What was it? If I don't, yeah, that was that. I don't have a fancy storage appliance with S3 compatibility. Atria has. But I have a virtual machine specifically built for this demo purpose, so no production data, thank you. And this one has an S3 compatibility. So an S3, if you don't know, is some other cloud vendor provided file format out there, but we are using that here. I have here a very big table, like 130 million rows or something. And you can see they are no longer 4 megabyte files, they are bigger files. And I have here a delta log. On this delta log, I only have now 1 row. If I open the same folder here, this is not in the same. This is on my device. On my device, we will kind of do all the good tricks shortly. If we look, the first delta format file, we can see that this one only has 1 file in it. And then I have second transaction, which has all the other files. And now when I click, on the Fabric and on the Fabric notebook, I have, it would be easier if you just put them in order. They were in order some time and then something happened. It's the shortcut version, looking for it. Lakehouse. Okay, well, let's write together. I'm a bit, no. It was in this notebook and down here. Yes, that's the perfect one. Here we have this one. This is, and my session just stopped. It doesn't matter. It's 5 seconds. I promised it was 5 seconds. Here we should have the fact internet sales big table. Let's test if it's already here. If not, there is a create statement for it. What's happening is that this fact internet sales big, it's not there. Thank you. I'm creating this from external location, and this external location is that S3 bucket storage coming from the on-premise system. And I'm creating that table. And as all the shortcuts are like standard folders, upper layers in Fabric don't understand that it's a shortcut. It's just a folder. So it behaves exactly like any other folder. You can run a SQL statement for that shortcut or that delta table created on top of the shortcut. And this is actually now invoking a query to on-premise via this gateway. And if I put the perf1 on, I see that there are 5.3 million rows or something in this table. Kind of this one is the interesting number, 355. And then I have a very fancy S3 browser, free and everything for non-commercial use and things like that. But I will upload that other JSON file to my Delta log folder, because that's how Delta works. If you've never kind of, on the morning, on Heine's session, we discussed on a very high level that we have Parquet files, Delta metadata and others. What the Delta metadata is, it's just that JSON file. So if I add this JSON file with kind of next transaction number, 0 is the first, 1 is the kind of second, to my S3 storage on the on-premise, and rerun this statement. Let's take that one. So that there we have it kind of as a reference point, and rerun this one while looking for our, I don't know, hopefully, please. Did it already come? No. All the demos worked so well up until now. Now it started running. Yes, thank you, thank you. So it goes to my on-premise storage, and when this goes down sometime, hopefully soon, thank you, please. Now it went down. I have a new number, which is 124 or 24 million. So, and I'm doing a sum of some column, not just cheating that I would do count, because if you see demos doing on Parquet files count, that's on the header. So that's not actually touching the files, but when you do a sum, you have to read through all the files. So we have a table available in our lakehouse pointing to our on-premise storage appliance, which I kind of, with the notepad, pretty much modified the content, and that affected the table kind of internals, what's the data in it, and that's actually reachable from the semantic model also. So we don't need ETL at all. We only need the Parquet files in the storage appliance. And then that's kind of immediately available. So they have some devices, IoT devices, that can produce Parquet files. So we're basically creating Parquet files, and then we have a PowerShell script running loop through the Parquet files, adding them to the Delta context in the folder, and it's immediately available for querying outside. So kind of 5 minutes to load and analyze huge amount of data without moving it. And even better, okay, now I forgot to pause this, but this, if you would integrate over that size of the chart we had there, this is 1.4 gigabytes, this table in Parquet files. It didn't read 1.4 gigabytes of data from the on-premise when I ran the query. Because what Microsoft is not also telling to us is that that new gateway we have, if you go to the gateway appliance, it's a virtual machine. You install this application in your own virtual machine or physical server, and then you will open the query aggregation, aggregation log, something, query aggregation report, this one, and I will load it over here, and then I will scroll all the way. Let me zoom out so that I can scroll all the way to the down. What you can see is it actually uses a direct query towards your on-premise infrastructure, which is kind of cool if you think. It's a file system. It's not reading the files to Fabric to process there. The on-premise data gateway has a knowledge to read the files, push the predicate to the Parquet files, do all the vectorization it needs to read the files as efficiently as possible, and output the content. So we have like a SQL engine in our gateway reading that. So kind of the amount of data required to transfer to that report is very minimal, because all the kind of the SQL statement in the Fabric was pushed down to the gateway service, and that introduced that, okay, what are the semantics of the Parquet files, and read them from there. In addition, it will do caching. Fabric will do caching. So if I now rerun the query, it will not go to the on-premise storage because it knows that nothing has changed. But still, it didn't have to read the 1.4 gigabytes, or in customer case, the 2 terabyte files, because it can kind of do all that thing on the on-premise. And this gateway is not licensed. It's free, so you can put as big of a virtual machine or something, because SQL people know that core is very costly. If you need an enterprise core, it's very costly. This is not being licensed, so you can be kind of huge device, and then your queries just run. So 2 terabyte file or table, immediately when the file lands, you will have a Power BI report with the semantic model reading from that. And I think that's cool. Thank you. I'm there.